Welcome back to School of Civil Engineering. This is Tekla with another new video. In our previous video, I've shown that how we'll design a single bar reinforcement, single reinforcement concrete wall. So that is available in our previous video, and in this video, I'm going to show that how we'll design a double bar reinforcement concrete wall. Okay, with column or without column. So if you're new here, you can watch our previous video that are already uploaded in our channel, and if you're a civil engineer, then don't forget to subscribe to our channel for the next update. Here all video are available for civil engineer. So let's start. So first of all, here in our first three video I have used that software. This is the quick machinery 4.0. Now we'll use quick concrete wall. So here I'll click here, and after that you are seeing that single curtain wall. In first time we have used that, now I will use that. So click here and give a name what you want, then press OK. After that you are seeing that this is a double curtain wall. Okay, double uh, reinforcement wall. So suppose you need to draw a you need to design a drop wall or any wall that required for you to work. So you can use that. So from here you can use that. You can use that wall by using uh, double reinforcement wall with columns. So how we'll done that in this video, I'm going to show you that. So first of all, you have to go here, criteria, and you have to select the building code. So here only IVC International Building Code is available. So 2012 I will use that. Then load combination. From here you can use ASC, American Society for Civil Engineers, and IBC International Building Code. Then from here, suppose I am going to select that. So use seismic provision. If you want to use seismic provision, so you have to click here. Otherwise you have to uncheck here. So check here, and then uh, design displacement. What is the design displacement? How much displacement you will consider. So I will consider 3 inch maximum 3 inch displacement I will consider. So after that, actually this is almost same as in our previous video, that's why I'm going fast. So the link are given in description so you can see it. And here materials property FC prime. FC prime is the here the compressive strength of concrete used for the wall. So here uh, FC prime I will consider 300 psi. Then Fy, and also if you need to change that unit, by clicking here units, you can change here any unit. Okay, you can change any unit from here. So close that. After that here 3000 psi and 60,000 psi. Okay, Fy means yield stress of river including ties used in the wall. Okay, so here's the wall unit weight. You can change your wall unit weight. So it is given 145 pound per feet cube. So let it okay. Then here have two options: apply wall weight. Apply wall weight. Yes, obviously we'll apply wall weight. It's self weight, and here shear is at wall top. So suppose if here you can read that, and if you think that in shear top portion they have shear force, working shear force on that wall, so you can select that option, otherwise cross that. So select that. Now after that you have to go here, define load. Okay, so you have to add load. So see here, the load is the vertical or shear force, is the P is the axial load, and here the M is the moment. So I'll go ahead add. So first of all add dead load. So from here what will be the dead load? Suppose I will consider our dead load is 100 keep. Okay, then I will consider our moment is suppose 20 feet keep, then our share force suppose it will be 40. Okay, so this is our load, axial force, shear force, like that. So press OK. After that, again go here, add, then for live load select, suppose it's 80, sorry, 80 keeps, its moment is 25 and axial force is 20. I'm just considering a random value here. You have to use your value according to design or according to requirement. So we have applied it all of our load. Then we'll go here wall. This is the view of our wall, and if we go here, this is the elevation view. Okay, this is the elevation view, and here this is the elevation view, I mean reinforcement layout here, and here's the special boundary element. Okay, so here the special boundary element figure, and so we'll go here wall. After that, length of the wall. What is the length of your wall? Okay, so what will be the length of your total length? So suppose our wall length will be 20 feet, then it's 20 feet. Then what is the height of your wall? Suppose our wall height will be 10 feet. Okay, then thickness of our wall. What will be the thickness of our wall? Suppose it will be 12 inch. I'll consider that it is 12 inch. After that, if need, we'll increase that or decrease that. Okay, so after that, here wall cover. What is the wall cover? I mean clear cover, so 0.75. Otherwise you can increase that. Okay, 0.75 is okay. After that, wall reinforcement. What is the wall reinforcement? I mean what is its reinforcement? So vertical versus, what is the vertical versus? Is the, this is the vertical versus. Here this is the vertical versus. So what is the versus vertical? If we consider number 4 bar. Okay, so after that, vertical bar spacing. Vertical bar spacing, what will the vertical bar spacing? Okay, suppose it will be 10 inch. Will increase later. So our horizontal bar size is number 4 bar, and our bar spacing also will be 10 inch. Then horizontal bar anchor. If you need to use horizontal bar anchor, then use it. So if you use straight, then straight. If you use 90-degree hook, then it will be 90-degree hook. Then if you need to provide the confinement bar, so you can use a confinement bar according to requirement. So if you use confinement bar, I think you have to give here its value, so I'll not use any confinement bar. So here is the, you just see that the figure are changing. So if you use confinement bar, it will see you the data. The, what is the meaning of confinement bar? The confinement bar is I mean the bar connected to that two side. So here I mean that two wall, that wall and that wall will be connected by a tie bar. Okay, so what is the bar spacing and extend to confinement? Suppose we know that at the actually we know that at the near of our support, the shear occur. So to reduce the shear failure or some kinds of failure, here we use confinement bar. So here is the tie bar size. What is the bar size? You can use number 3 bar. And tie spacing, what will be the spacing? Suppose if you use 10 inch, then extend to confined from that support. Okay, from that that support, what will be the extension from here? I mean from the in support, what will be the distance of your confinement bar? So if suppose if I want to use 60, just see that if I use 60, it will increase till that distance. So it will also use a confinement bar here, right? So I will do not use any confinement bar, or you can use that, no problem. So then unclick here. Then column has, I mean it has column. So if you think that I will not use any column, so you can give here like that, right? So it will not use any column here. So has a column. So the column length, this is the column length, here is the column length, okay, and here is the column thickness. So what is the column length? So our, suppose our column length is to suppose a 1.5 feet, okay. So it's 1.5 feet, and here just see that when we are working it's changing, value are changing, and also it's showing the clear spacing, insufficient clear spacing. So we have to do that next time. So after the column thickness, what is the column thickness? This is the thickness, this is the length, and this is the thickness. So 30 inch will also use 18 inch, 1 8 18 inch. So just see here now the parallel sidebar count. So what is the in parallel sidebar? What will be the bar here? 1 2 3 4 5 6 7. It's showing 7 bar. So we'll use only 2 bar first time. So 2 bar. Then perpendicular will also use 2 bar. Just see here. Now 2 bar is okay for our that load. And after that we'll go bar size. What is the bar size? This is the these bar size are using the 11. So we'll decrease that. We'll use only number 5 bar. So just see here now tie spacing, it's showing the tie spacing is not okay, so we have to decrease the tie spacing. So here is the tie spacing. If we use the tie spacing, what will be the is it's 12. So if we use 10, just see that now it's okay. So for tennis it's okay. And here is the for special boundary elements, here is the special boundary element. Suppose if you haven't a special boundary element, then it will be just like that, okay. So they have no special boundary element here. And just see that there's the hook. If you do not use that hook, it's a state. Just see that it will be a state like that, or none, it will be none. There any hook will be none here, just from it will start from that point. But we'll use hook 90 degree. It will increase, I mean it will be very good binding with that column and wall. So I will use a special boundary element. Suppose if you need anywhere special, it will design both, um, where a special boundary element is not required and here is the boundary special element is required, it will design both of it. So here if you vertical extend, here vertical extend, what will be the vertical extend? So from, I mean from how distance, from what distance it will use the vertical extend. So you can use that vertical extend or not. Just see here, if you see here, there have a more divert than that position from that if you see here, the diameter of bar is less. If I show you, just see here closely, here it's this bar is more, its bar diameter of that bar is more than that bar. So if we, you can reduce that. Suppose if you reduce that, from here you can see the elevation view, okay. From here you can see that elevation view. So just see here, they have a bar till that layer, okay. They have a bar till that layer. So what it's showing the special boundary. So here it's showing a special boundary from that point to that point. And if you go ahead and if you reduce that special boundary, now see that they have no any extra bar here, okay. So I mean for the good design or for design per requirement, you can use that, okay, the special boundary. So if we use a special boundary and just see here, sorry, just use a special boundary and see here, they have a reinforcement till that. You can also increase decrease that, that depend on your design criteria. So from here, suppose it's if you 10 feet, the horizontal element 16 inch, Then tie size, if we use number 3 tie, and also here the web cross line bar size, if we use number 4, and web parallel confinement, it's if we use 4. So again here web tie spacing 6 inch, it's giving 6 inch. You can increase or decrease that according to requirement. Now just see here our a wall, everything are okay. So we have provided everything here. Now suppose we're seeing that our the thickness of all is okay for our design load. So we'll go here and we reduce our thickness. If we use thickness 10 inch, it's also okay. Our design are also okay if we use thickness 10 inch. So if I go in 8 inch, it's also okay for our load. For 8 inch, it's also okay. Now if we go for 6 inch, just see here for 6 inch it's not okay. For 6 inch it's not okay. So if we will use 7 inch, for 7 inch it's okay. Now we can also reduce the column size. So we'll reduce the column size from here. Column that is 1 feet, and also I will use 12 inch. Just see that for 1 inch and 12 inch, that design are also okay. So will not reduce anymore from that. So just in this way you can do the mostly probable economical section, or you can design that by using that element. I mean, you can increase or decrease anything. So suppose now if we here bar size, if we decrease that bar size here, it's when we have decreased the bar size, it's showing the wrong. So if we use the number 3 diver, and if we increase the spacing suppose 18, then it's okay. So in this way you can increase, decrease, or you can do anything here according to a requirement. So I think it will be okay for you. So if you hear, that means that is helpful for you, and if you think that that is helpful for you, just press the subscribe button and also press the bell icon. And don't forget to like our video, comment to our video, and don't forget to share our video with your engineer friend. So thank you very much. S12, stay connected till next video. I'll come back with another new video. So S12, stay connected till.